Good morning, everybody. Good evening, actually. Good morning from sunny California in the States. It's, what is it now, 9 o'clock in the morning, and I appreciate that you have a lot of places you could be. It's much later in the day for you, so thank you so much for taking the time to be here. Welcome to Bootiful Kotlin. My name is Josh Long, and we're going to talk about some of the latest and greatest uses and applications for the Kotlin programming language as it applies to building Spring applications. And so with that, as our understanding of what we're going to do, let me state some obvious things. My name is Josh Long. It's so nice to be here. I am a Kotlin GDE, Google Developer Expert. I am a Spring developer advocate. I'm a Java champion, sponsored by Oracle. So I work on the JVM. I love the JVM. I have a Twitter. If you have questions, comments, feedback, whatever, don't hesitate to reach out to me. I'm at StarbucksMan on the Twitters. And my email there is josh@joshlong.com. And the code that you can use to follow along today is github.com, joshlong, Bootiful Kotlin. I work on the Spring team. I've been there for 10 years now. I have some videos on Safari, one of which is on Kotlin. If you want to find an even longer many-hour discussion of what we're going to talk about today, there's a video on Kotlin. I have a book called Cloud Native Java that I wrote 3 years ago, all about how to build applications that survive and thrive on the cloud in terms of Spring Boot, Spring Cloud, and Cloud Foundry. I have a podcast that I do every Friday that's just me talking to people that are smarter than I am. And so I've had episodes there with people from the Kotlin team, right? Like Hadi and Eliza. So like lots of different guests there that I think you'll find pretty interesting. This Week in Spring is a blog that I do every Tuesday. It's a recap of all the news that's fit to print, or rather reprint. And every Wednesday I do a screencast called Spring Tips, where I just look at some corner of the ecosystem. And of course, I'm working on a book called Reactive Spring. So you can buy that book now if you want. It's going to have a whole section on Kotlin. Because obviously reactive programming in the world of Kotlin is very interesting, as we're going to see in today's presentation. So when we talk about Kotlin, what we care about is the productivity gains that we can get with it, right? I care about languages, not because of any one particular language feature. I care about languages because of the implied productivity gains that I can get, and I don't care how I get them. If it's through the ecosystem, great. If it's the language syntax itself, great. But I want those gains. I want to be able to make sure that I'm actually better off for my use of Kotlin. And so Kotlin has become one of these mainstream languages now that has, in the last 5-10 years, really earned its place as the second most widely used JVM language after Java itself. And that number, that usage has only grown in the last few years. And it's not hard to figure out why, right? There's several things that I think contributed to its success. One is the language team itself. The people that work on the language are very pragmatic. They are very interested in making Kotlin the premier place to run lots of different types of workloads, lots of different types of applications. And so they've been very willing to accommodate particular use cases. So when the Android community started using Kotlin in earnest on Android, the Kotlin language team worked very hard to make sure that that was a very nice experience for people building Android applications. And Android is a very good example of where having backwards compatibility with a very old version of the JVM and still being able to have a nice syntax is very valuable. So you can write Kotlin code that targets something as old as Java 8, which nobody should be using in production today, right? right, guys? Right? You're with me, right? We're not using it in production today, right? Anyway, you can be able to target something as old as Java 8, or even, gasp, even worse, something like Java 6, and still get new language features from Kotlin. That ability has made it a very, very popular, very, very useful language in the Android ecosystem. And it has shown, right? People were talking about their use of Android and Kotlin years ago, as far back as the beginning of Kotlin, right? During this time, people were starting to see that they wanted to be able to write modern applications without having access to modern JVMs. And this made it very popular. It got so popular, in fact, that about 3 years ago, in 2017, actually no, 4 years ago, 2016, the JetBrains team and Hadi in particular invited me to come speak at the very first Kotlin Conf, because I had been a big Kotlin fan and I was very impressed with all the things that they were doing. And so they invited me to come speak at the very first Kotlin Conf in San Francisco. Now, I live in San Francisco. I thought San Francisco would be a nice place to go during this particular time. And so I was very excited to have the opportunity to fly home and see my family. And I thought it would be nice to be able to participate in this conference in my basically my backyard, right? Just a mile away from my home. I could walk, right? I never get to walk to conferences. And so I was very excited by this opportunity. Plus, I love the Kotlin ecosystem. It's very, very active, it's very vibrant, and people are very friendly. And so I thought it would be great to see all my friends in the Kotlin ecosystem. So I accepted this 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 opportunity and thought nothing of it. Then Google I/O 2017 happened, and at Google I/O 2017, they announced that Kotlin would be a supported language on Android officially, right? This is not, it was not official before. You could do it, it was workable, it was possible, but it wasn't like it was a well endorsed, well understood path. Only the really, really large applications ever bothered to make that jump at first. And then, of course, it got easier, but it took leadership, right? It took community leadership to get to that point. So they said they endorsed Android, and this was sorry, they supported Android, and this is a big deal because it meant that now anybody who wanted to use Kotlin, who was looking at nice languages like Swift over in iOS, suddenly they had a working alternative that they could use in their code, and that became a very, very big point for the language. The community started to grow around it. Things started to develop. Tools started to blossom around it. Fast forward another year, 2018, suddenly Google says, not only do we support it, but we endorse it. So here I was in 2017 watching Google I/O, watching these revelations about how they now support it, and they want people to consider using it. And I'm thinking, oh, this is good news, right? This is going to be big. I could not have imagined how big. I went to that Kotlin Conf show just a few months later, and it was huge. It was 1,500 people for the very first show, very first installment, right out of the box, never done before, very small marketing budget. And there was 1,500 people in San Francisco, right? It was a very, San Francisco is a, um, we have Silicon Valley and so on, but you'd be surprised by how hard it is to get a lot of people that talk about JVM software in Silicon Valley, right? It's they're very hipster in Silicon Valley, so sometimes the JVM is not the most popular thing. So here we are, 1,500 people, very first show. Now consider that a lot of shows don't even ever crack 1,000. They never get past 1,000 people. So I was very impressed. The other thing that contributed, I think, in some small part, was the support for Kotlin in Spring. Now, back in 2016, we supported Kotlin. We said we're going to support Kotlin on Spring-based applications, and all you had to do was go to start.spring.io, which is where I am right now, and choose Kotlin. And when you chose Kotlin, you got a brand new application. Now, what you would get here is a language that that you could use, but it was not any particular library, right? We didn't actually have any support in Spring itself for Kotlin. There's no Kotlin specific APIs that you would get. That has since changed, right? So since 2016, we've done a lot. And then in the latter part of 2017, we released Spring Framework 5. Spring Framework 5 is the first version of Spring to include Kotlin APIs in the jars for Spring Framework itself. And so as you will see, I don't have to do anything special to make a Kotlin work. I can just add it to the class path, add Spring to a Kotlin project, and it'll work. So I'm going to go ahead and just quickly spend a few minutes here to introduce you to some of the actual basics of the language. Let's go ahead and generate a new project here at start.spring.io. And I like start.spring.io because it's a great place to generate applications. And also it gives me an indicator about what the current state of the art is. So I'm going to use Kotlin. I'm going to use Maven, but you can also use Gradle. And the nice thing about Kotlin is that it has a huge ecosystem. This ecosystem integrates with everything. So if I chose Gradle, I would actually get a Kotlin-based application whose build file, the Gradle build file, was also in Kotlin. That's very convenient, right? I can now have an application that is end-to-end Kotlin. My code is Kotlin, my build file is Kotlin, and this is also one of the main features of the Kotlin language, is that it's taking this write once, run anywhere mantra very seriously. Well, seriously enough that it's worth paying attention to. It's not perfect, but the idea is that you can write code in Kotlin that targets the JVM, and then if you wanted to, you can extract out certain parts of that code, and then extract it out into a common module that targets other platforms. So you can actually use Kotlin.js. Kotlin.js transpiles your Kotlin code into JavaScript. So you could write your React application in Kotlin, or you could write your Angular application in Kotlin, or your Vue.js in Kotlin. I wonder if one day we'll see a Vue.kt. That's probably already there. So there's the Kotlin.js compiler knows about and works with TypeScript type definition. So you can actually use the auto completion that you would get from TypeScript definitions within your Kotlin experience. That's a very compelling opportunity. There's also Kotlin Native. So the Kotlin team built an LLVM backed compiler. So you can write Kotlin code that targets this LLVM compiler, and it in turn can be compiled to anything that LLVM can support, including, very importantly, WebAssembly. So here we have a very interesting opportunity. Now you could write cryptography, you could write any kind of important algorithms that you want that need to be performant, maybe 3D code. Any of that stuff can target WebAssembly, right? So now you can run that in your browser or on your local machine, right? It doesn't have to be in the browser these days. WebAssembly is a common runtime. And then you can take your Kotlin application if you want and run it on the JVM, right? So you can write your Spring Boot applications using Kotlin, as we're going to see. And of course, you can run it on your phone, on Android. So now you have this incredible story where you can actually write code end to end in Kotlin, right? And this is actually a very interesting opportunity. Now, as you're going to see, the syntax is not that hard. It's not that difficult. And so as a result, the benefits you get from using the language, you can get pretty quickly. That said, I don't think that the language is the largest reason to embrace a community, right? I think the reason that you would embrace Kotlin is because it has embraced multiple communities. It has tried to be a great fit for lots of different communities. It's very pragmatic. It doesn't say it's only our way or the highway. It says we want to make everything that wants to be based in Kotlin better. And so the feature here isn't the language itself, it's the people that build it. It's the Kotlin team. That's the reason that this language has become successful. Ultimately, is because of this flexibility, this willingness to accommodate lots of different ideas and approaches, right? This big tent philosophy. So if you want the most functional language in the world, this is not that, right? If you want the most Java-like language or most object-oriented language, maybe this isn't that either, right? Maybe you could do better with Smalltalk or something, right? But it has a nice blend and it feels very clean and it's consistent. And so for day-to-day programming, it has become very, very nice. And because it's such a large community, right? It's because it's such a big community, I don't feel like I'm ever going to get myself into a situation where it's impossible to figure out what's happening. So really, at the end of the day, what I get is the ability to write code against multiple platforms and to write code that uses these native platforms in particular ways. And then I get the ability to write common code that can target all of these platforms, right? Now, I'm going to open up my intro jar there. Here we go. We're just going to look at the language syntax itself, right? We're going to look at some of the basic features so that we are not confused about what is happening. I just want to introduce some basics. So I'm going to open up my IDE. Again, it doesn't matter which IDE you use. Anything will work just fine. The nice thing about this language is that you can use the different tools that JetBrains provides to write the code in the most appropriate way. So if I wanted to write an Android application, there's the Google and JetBrains co-developed Android Studio. It's based on the JetBrains platform. Very nice experience. If I wanted to write native code, I could use CLion, C-L-I-O-N. CLion provides the ability to write C++, C, Objective-C, that kind of stuff. And CLion also supports Kotlin Native. And remember, when you write Kotlin Native code, there are APIs there that let you handle pointers and that let you address libraries, dynamic libraries. So you can write native code just like you would with C. You can actually use a tool to very easily link against headers in the C ecosystem, for example. So it's appropriate that you would do that from within something like CLion. And so on, right? The support is very consistent across all the different projects that require it. Okay, so this is a Spring Boot application. Let's get rid of that for now. Let's just focus on public static void main. Okay, so this is our intro to Kotlin. This is a very simple public static void main application. Notice that I'm not using the public static void main string arguments array. Also notice that arrays have a consistent syntax, right? So it's a generic. String is a generic of array. It's not a separate syntax that only works for arrays. It works consistently. And also notice that the variable type is on the right, right? So here's the thing on the right, and the name is on the left. Also notice that since it's not being used, and since it's not required all the time, you don't need it, right? So I can actually do print line hello world, and if I run this, I'll get an application that will actually just print hello world. So let's go ahead and compile and run this. Oops, it's looking for a class. It doesn't exist. Run this, please. There you go. Hello world works. Hello world runs again. Okay, so now we have a very simple application. It's easy to create variables, right? So val name equals Josh, right? I could declare the type. I could say string, equals Josh, and so on. There's lots of convenient builders as well. So names equals array of, Oleg and Sebastian. Okay, so I can do that as well. And of course, if I wanted to, I could type this as well. So it's an array of string. You can have these are effectively final. They're final variables when they are prefixed with val, but they could be mutable, right? I could say mutable equals mutable name equals whatever, some Bob. Okay, so there you go. And I could change that name now. I can say mutable name equals Jane, right? I can do that. I cannot do this because these are effectively final. Notice that I get some consistency. I get some consistency here. I can use val. There's the name and there's the type. If I don't want to have the type, I don't have to have it, right? But it's still val and then the variable name and then equals and then this. And so this is different from Java, right? Java is very different. Here you have name equals Josh, or you can do var name equals Josh. But in Java, I can't mix in. I can't get the left side of my lines of my code will be different, right? If I have to. This is most obvious when you start to do things with lambdas, as we'll see in a moment. So I've got mutable variables, I've got immutable variables. The other thing that you need to care about is that Kotlin cares about nullability. So when I say nullable name, it wants to know if this thing can be made or set to be null, right? So I want to say nullable name equals Josh. Var, right? Or I can say nullable name equals null, and it allows me to do that. I can initialize it to null like this. I could say val, and then just initialize it to null like that. The reason it cares about nullability is because I put this question mark there. If I don't put this question mark there, it fails to compile. It says, hey, you're trying to assign null to what we assume is an otherwise non-null value. So that's a very important feature there that makes working with the type system very nice, right? Very convenient. And a lot of cases where you might use an optional, suddenly maybe you don't really need to, right? And the nice thing about this is you can actually do some very interesting things. You can say, okay, I want to dereference part of a nullable variable, right? So I can actually, I can say, give me the length, right? Notice that I have to do a question mark there. If I don't have the question mark, this fails because it says, hey, this could be null, right? So I have to say null. I have to say, check if it's null. And if it isn't null, return the value of this. I can even go a step further. I can say, I'll return -1. So var length equals either the value of nullable length, or if it's not possible, -1. I default to that. That way I avoid null pointers, right? You can create functions. You saw that we're already in a function, right? So a simple function with a name is or whatever, a number, right? I can create a function. I can create a function with a return value. By default, unit is equal to void, right? So void is unit. And I can, return a string, right? I can return or return a number. I can also do another function, right? Like this. I want this to be an int. I can do another function. I can say return, and I just return 1 that way. That's the same thing, actually. Instead of me explicitly declaring the return value, if I have it as an expression, I can just return it, right? I can just say inline blah, blah, blah. At runtime, this will be compiled into basically the same thing. I can be explicit about that if I want to, but I don't need to. You can go a step further, right? Functions are first-class citizens here. So I can actually create a variable, my func, which is a function that takes a string and returns an int, and then I can just say, 1. Right? I need to declare the string parameter. So maybe the string is a name. I can declare the parameter there, but I'm not using it there. So look at that. The compiler says, hey, you're not using it. If I want to, I can just omit the variable name altogether, or I can just use the implicit variable name. So print it is the implicit single variable that we've got there, right? Or better yet, I can actually return that length, right? Return that. So there you go. You can see that it's very nice to be able to describe functions this way. And I can create functions that work with other functions, right? I can say that this function takes a callback that is itself a string to int. And the result is that I can now work with that. You can do other things that are pretty interesting, actually. You can actually create functions that are based on other, that are rooted or that are contextualized to be on other types. This ability to have first-class functions is very nice because I can use this. I can say, okay, let's do a callback here, and I'm just going to return 1. Okay, that works. But it's the only parameter, and so Kotlin says, hey, that parameter, since it's a lambda, it can exist outside of the parentheses. Or I can just drop the parentheses altogether, and that's the same thing. That works the same way. So that gives the ability to create really nice DSLs. Okay, so we've looked at a number of different things here. The other thing is that in Kotlin, you're going to want to keep things val as much as possible. You want to keep them val. When I see var, I think of it as a kind of a code smell, and that means that things should be immutable or final rather by default. So the question then is, well, what about all the stuff I need to initialize? In Kotlin, there's a lot of ways to avoid having to initialize stuff after the first line, after the initialization. So let's say I wanted to do something complicated like an if-else. So I can say val sum equals, and here I can say if math.random is greater than 0.5, then sum is equal to 10, else it's 20, right? That's a very simple if else, but I can put as many lines as I want in there. You see, the if else is an expression. It gets assigned to this variable, val int or val sum int, right? There you go. So there's the very simple assignment. I can do all sorts of other things, like we have smart expressions. In Java 14, there's a preview feature for smart switch expressions, but we've had that same kind of thing in Kotlin for a long time. So result string equals when, and then the value will say, okay, let's say when sum, and here I'm going to say when sum is equal to 10, then I'll say 10. When it's equal to 20, right? Else, shrug, right? We don't know, right? We don't know what the value is. So that way I'm guaranteed to have a value. If I did this, it wouldn't compile because it would, there's a range of values that it could have, and we haven't accounted for all of them. So this is now another example where Kotlin is just very, very convenient. You can do things in a functional way as well. You saw me do this earlier, array of A, B, C, and I can do a for each if I want, right? Print line it. But I can also do things in this sort of generic imperative way. So I in 0 to blah, 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 and then print out it, okay? So there you go. Sorry, print out I. So there you go. We can do all sorts of things that are pretty nice there. One of my favorite things is the ability to describe functions that extend existing types, as I said earlier. So let's suppose I wanted to have a function that lived on Java lang string. Okay, so string equals print line name says this, right? So what I've done is I've extended Java lang string. Now I can say Josh.announce, right? Or good morning. This is a very inverted, very weird example, but you can kind of see the idea there. Okay. So now if I run this all, let's see what we get. There you go. Josh says good morning. Okay, so my friends, we've looked at the very, very simple introduction to Kotlin, the language. We're going to see some more features as we work. Let's go ahead and go back to start.spring.io. And what we're going to do now is going to demonstrate some of the absolute basics of working with a language. So I'm going to create a new application called Basics. And here, we're going to use old Spring APIs that you could have used yesterday. You know, this is something that's been around, stuff that's been around for years and years and years and years. So we're going to build a JDBC-based application that talks to a database, a SQL database. So we're going to use Kotlin, and I'm going to hit generate. Now, I like all the stuff that I'm showing you here. I like the new version of Spring Boot 2.3. And there's a lot of reasons to like it, by the way. The version that we're using, Spring Boot 2.3, supports a lot of features that make it even more relevant in the cloud. So, for example, Kubernetes probes and graceful shutdown so that you can actually drain off existing traffic. There's built-in support for building Docker images. You just say maven spring-boot : build-image, and it'll generate a Docker image for you based on your application using the Cloud Native Computing Foundation's build packs specification. There's also support now in a separate project called Spring Growl for building native images, and that works with Kotlin as well. I don't have a lot of time to show you that, but I would hope you'll watch my Spring Tips, Spring and Growl video here. There's a separate one I did, Spring Tips, come on. Okay, well, this is one from April. This is old. Look for the newer one that I did a couple weeks ago. It's part 2. Okay, so Spring Tips Growl part 2. Come on, Google, do the thing. There you go. This is from June 16th. So very interesting opportunity here. You can take existing applications and compile them to GraalVM native images. Now, GraalVM, of course, is a C1 replacement, a just-in-time compiler replacement, but it's also got this nice feature called Substrate VM, and which helps you create native images, and that's a very interesting opportunity. So I've demonstrated that in that video. I can show you the examples, but I won't run the code because it takes too long to compile. So code, Spring and Growl, okay, and I've got a bunch of applications here. I can go to the JPA application. JPA is using Hibernate, right? Hibernate. It's using Apache Tomcat. It's using all the usual suspects. And this application is already compiled. So if I start the application, Control C that, that's crazy. There you go, 0.27 for Hibernate, right? Very, very good numbers there. And then I go to the other ones, like the reactive one, and target native image. Okay, reactive, there you go, 0.144 seconds. That's actually really high. I don't know why that's so high. There you go. That's a little bit better, 0.139. Normally, when I'm not screencasting, I have 2 different things that are recording my screen right now. Normally, when I'm not doing that, that hovers at below a second. Below 1/10 of a second for those applications. So these applications are ideal because they're small in memory footprint and they run pretty steadily at the runtime. So they're ideal for containerized environments. All of that is supported by using Spring Boot 2.3. That said, you don't need to use Spring Boot 2.3. You can use Spring Boot, again, 1.x had support for Kotlin, right? We've been supporting Kotlin for a long time. Okay, so we're going to build an application that uses JDBC. We're going to hit generate, go to the downloads directory, UAO basics, right? This is a basics application. And this application is going to use the Kotlin language, of course, right? We're going to use Kotlin, but we're also going to use a library, an ecosystem dependency from the Kotlin ecosystem, right? So this is one of the things that's really nice, is that the ecosystem itself is very good about making it so that I can work with Kotlin and Spring in a convenient way that's natural. So I'm going to add the dependency management sections that I need to be able to use this language as well, this feature as well. So I'll paste in those repositories there. So I've got dl.bintray.com, Kotlin exposed. We're going to come back to that in a second. Let's now build a traditional sort of JDBC-centric application. Again, you've done this application a million times, I'm sure. If you've used Spring before and you've talked to a database, then you've written code that looks like this. So JDBC : Postgres QL localhost orders, username orders, password orders. Okay, and what I'm going to do is I'm going to write an application that now writes to the database. I'm going to just create a simple interface. So interface customer service. I'm going to create a function that returns all the records in the database. Okay, so I need a method to return one by ID as well. So customer. So this might be null, so I'm going to make it nullable. I need a DTO there for my data type, so I'm going to create a data class, and it'll be a class that actually has fields in it for the ID and for the name. Here we go as well. So there's the two types, the data type. Now this is a class, it's kind of like a Java 14 record or a case class in Scala. It's a class that has getters, setters, toString equals hash code, and storage for these fields, as well as constructor parameters, right, for all those fields. So I don't have to do anything else to get that to be usable. And now I want to implement that. I want to create a simple JDBC customer, JDBC template customer service. Okay, so the JDBC template is an interface. It's a type that's been in Spring for 18 years. I mean, it's been around forever. I know a lot of us who first started using Spring, when we first got into it, we started using it because of things like the JDBC template, which are standalone, very convenient libraries. I know a lot of people, even 15 years ago, when they couldn't use Spring, they would still import that library just to be able to have access to the JDBC template, because using JDBC by itself was not fun, not great, not exactly the best. Okay, so what I'm going to do is I'm going to use this JDBC template to do some data access. Okay, so I'm going to implement this. Now, notice what I've got here. Notice that this customer, this function, first of all, I have to override it. I have to be explicit about it. Second of all, notice that it's returning a customer, and I've got this macro, this thing here that's saying, hey, to do, not yet implemented, and the compiler is not complaining, right? That's weird, right? Imagine if I did that somewhere else. Imagine if I said fun to do, right? Whatever, just who cares? And then I did to do. Look at that, it's complaining now, right? It's actually saying, hey, the compiler is expecting a return value, and yet you've got nothing here. And yet when I have this here, it doesn't expect a return value. If you look at the code, you can see that that's actually an inline function that returns nothing. So earlier I said to you that unit is kind of like void. Nothing is another kind of void, but it means don't expect this thing to return. When the compiler sees that, it says, oh, I'm not expecting a return value. So if you have something that's going to keep polling a source, a network source or whatever, or doing something that's in a loop that's going to happen forever, it's never going to return except for an exception, then you can return nothing. At compile time, when that gets turned into bytecode, it just returns void, basically. It's the same as before, but the compiler treats it differently at this level. So that's very convenient for this kind of a macro. The other thing is that it is inline. You saw that inline, right? That tells the compiler to basically copy and paste the code definition that you saw here, right? This definition, it copies and pastes it into the call site. So it looks like a macro, right? Like a C++ or C macro. It's actually, there's no dispatch, there's no jump there, okay? Okay, so let's implement this. Obviously, this is fairly easy to do. So we say this.jdbc template which one is this? This is by ID. So what we want to do is we want to search for a particular record, jdbc template dot query for object, right? This is a old API, select all from customers where ID equals question mark. And the parameter that we want is the ID there, right? So we're going to put that in as a parameter for the query. And then I'm going to use a result set and an index, and I'll return a customer result set dot get int, right? So when I get that, result set dot hello, query for object. You see the problem here? I'm trying to do things a little differently here, and it's upset. So get int. It is what it normally expects is the row mapper to be the second place, and then the third place would be the arguments, like that. That's what it expects in the Java API, right? And so what I'm trying to do is do it the other way around. I want to have the parameter there, and then the callback, so that the callback can hang outside of the method invocation in a very natural way for Kotlin. So I'm trying to get it to give me the opportunity to import this. So there we go, ID. Okay, get rid of that. Come on. Query. Okay. For object. Oh, you're being silly. So one string, good. There. Okay. See, it's expecting. See what it just did there? It's offering to import something called org Spring Framework JDBC Core query for object. That's not a class. That's a function that extends the existing JDBC template type. That function is a Kotlin extension. It lives in the Spring jars and it extends the types that I've got in a way that's meaningful for Kotlin users, but which don't bother or disturb the view of the APIs from the Java API perspective, right? So now I have this extremely nice experience that is specific for Kotlin. It's like playing a video game where you can find certain hidden levels, right? Very, very convenient if you're playing in Kotlin. If you're using Java, it still works. It's still the same old API you know and have used for more than a decade, right? But if not, you have this very nice experience, right? So that's very convenient. I like that a lot. That makes it makes old APIs, even APIs that are this old, very, very approachable, right? And of course, existing stuff is just nicer as well. So this .jdbc template dot query for just query, and then select all from customers, because this is not an extension function, but the last parameter here is a lambda, and so I can just naturally hang that off the side of the function invocation like that. And so I can just do the same thing as I did here. Okay, call that this result set. Very cool. So there's my implementation. Now I want to just demonstrate that working. So I'm going to create a thing that actually runs all this. So add component, class runner. I'm going to use my implementation. It's going to be an application listener, application ready event. Good. So go, and maybe I should spell correctly. Good. So there's my overridden event. And what I'm going to do is when this gets launched, I'm going to use the injected customer service to look for each record. And then for each one that comes back, I'm going to find a particular one, record equals customer service dot by ID, it.id. So I'm actually kind of exercising both print line. The ID is record dot ID, and the name is record.name. Okay, so I'm actually using both of them there. I'm using the name and the ID. This could be nullable, right? So I want to tell Kotlin, hey, don't worry, it's okay, right? And so this was very frustrating for me the very first time I experienced this issue, and I didn't know how to resolve the issue. And I started to become frustrated. And what do you do when you become frustrated? You yell at the code, right? And that solved the problem. I was very impressed. I was very impressed that the language designers knew what I was going to do, and they made it so that it actually works. So what I've done there is I've told Kotlin, hey, don't worry, it's going to be fine. Just do what I tell you to do here, right? Okay, so there we go. We got a bunch of names there, right, that have come from the database. So now, we know that the application is working. We're using JDBC template. This is one way to do it, but as I said, we can use the Kotlin ecosystem library called Exposed. Exposed is an object mapper, and it's type safe, and it works nicely with Spring. And I've already got the Exposed Spring Boot starter. They built a Spring Boot starter that makes it so that it just works out of the box with a Spring-based application. So what I'm going to do is I'm going to create a exposed customer service, right? So class exposed customer service. And this is going to implement the customer service interface, implement those members. Okay, so now here, in order for this to work, I need to describe to exposed how my object works. And so I'm going to create an object. It's a singleton class that Kotlin supports. The idea is a singleton class that Kotlin supports, and there's only one of them. It's a great place to create static variables. So if you've ever used Scala, you'll know about this, companion objects and so on. Same idea, right? So this companion object is going to describe the structure of the table. I'll have an ID, which is going to be an integer, right? So in the database, it's going to have an ID column. It's going to be auto-incrementing. I'm going to have a name, which is a var name, and it's going to have 255 characters. And finally, I'll have a primary key, right? So, override val primary key equals primary key this.id. Okay, so there's my entire thing. That's the entire definition that Kotlin that exposed needs to know about. And now with that, I can build my exposed customer service. It actually provides an auto integration with the transaction demarcation as well. But in order for that to work, I need to run everything inside of my exposed within a transaction. So there's already a transaction manager, a platform transaction manager implementation that maps exposed transactions to Spring's transaction strategy. So it's just done for you automatically. Now let's implement this. Let's actually rewrite this code to take advantage of that. So I'm going to say customers dot select. And here I'm going to say select customers. I'm going to say select all. Actually, I want to get them all. So here we go, dot all. And then I just want to map each record that comes back. I want to map each one. And the way I'm going to do this, I'm going to create a new object, a new customer, kind of like I did with the Jdbc template. But I'm going to use the it parameter, the implicit it parameter that I've got there, to extract or to pull out data from the row. Now, I could use a custom API, but the designers of this API have very reasonably decided to use something that looks like a map, and maps are they have a .get call, and when you override that particular call, you can use indexing, right? So this is the nice thing about Kotlin as well, is that it realizes that operator overloading isn't so scary as long as you don't have to manage memory, right? So as long as you're not doing pointer arithmetic as you would with C++, then there's no reason to be scared of this, right? So I can actually index into an object. I can create custom indexes. I can override things like plus and minus and so on, and get this very nice DSL, right? Very nice APIs that seem to work more naturally with the way I think about the problem. Okay, so that's all the record by, I'm going to select all there. Now what I'm going to do is I'm going to select a particular one based on a predicate. So where customer.id.equals ID, right? And when that equals that, I want to map it just as I did before. So I can copy and paste this. And I want to get the first one or null, okay? So there's my re-implemented one. I'm going to comment out my existing customer service, Jdbc template one, because I want to have just one implementation for Spring. There you go. Now I like this DSL, I like this API, I like that it's so type safe and so on. It's very flexible. You can do joins and all that, and it works, right? Same kind of thing. Very convenient. And again, this is a library that started up in the Kotlin ecosystem, and it happens to be that they're very friendly, so they make it work with Spring, right? I love that kind of stuff. I love integration. I like the pragmatism. So my friends, we looked at how Kotlin makes existing APIs, traditional kind of stuff, all that much more fun. But what's really an interesting opportunity is when you use it for DSL. So if I go back to start.spring.io, create a new project, the DSLs in Kotlin are awesome. So I'm going to bring in Spring Cloud Gateway and the reactive web support, and I'll hit generate, and I'll open this up in my IDE, okay, DSLs. Now, there are APIs in Spring, as you saw before, that make existing APIs more approachable from a Kotlin perspective. They make it more idiomatic, more native. That said, there are also things that you can do that are DSLs that are completely different from what you would do otherwise. So let's create a Dsl application, and let's take a look at a typical Spring Boot and Java style application. Okay, so I'm going to create a web configuration class, and inside of this, I want to create a Spring Cloud Gateway endpoint, so gateway, and I'm going to inject the route locator builder. Okay, and I'm going to say RLB dot routes dot route, and here I'm going to provide a route specification, right? So the specification is it.uri. If it matches this, if it matches this path proxy, then I want to send it to another downstream location. So in this case, that might be the spring.io /guides, right? So I'd say it.path uri equals http spring.io /guides. But the problem is I've already got a path. I'm detecting a path in my gateway here. And the gateway is going to act as a proxy. So it's going to detect the path, and it's going to send the request to this target. And the problem is that the target has another path. So in effect, the result would be spring.io /guides /proxy, which I don't want. So I'm going to transform that by saying it.setPath equals guides, right? So now I'm actually transforming the incoming path and replacing it with another. So that's a Java-esque Java DSL there for that. I can also create functional reactive HTTP endpoints, right? I can use the functional reactive starter there, and this looks like router functions dot or route, right, like this dot build, right, and you can just easily express these things like so hello, and this can become a handler function. So given a request, I'm going to return a server response dot okay dot body value hello world. Okay, so that's a valid but Java a very similar, very Java-like Kotlin application. Not great. We can do better. So it turns out there's a native DSL for HTTP endpoints. So I can actually say bean fun HTTP endpoints 2 equals router, and here I just want to say hello, and here, okay, router, good. And here I'm going to return a server response dot okay dot body, and then the value will be hello world, right? Much better. So I can get rid of this one. What about the gateway? Well, Spring Cloud Gateway has a DSL as well. So bean gateway 2 equals, and I'm going to still use the route locator builder just like before, but we can use the extension functions to make the experience a little bit nicer. So rlb dot routes, and here I can describe a single route, and here I can describe the predicate that matches it, path / proxy, and the filters set path guides, and then the URI, right? So again, much cleaner. Looks like I'm doing configuration almost. What did I do for the downstream one? Yeah, Spring.io. Okay, there you go. So much better experience compared to this. And again, it's just the small things like that, right? There's lots of DSLs in Spring that make using Kotlin nicer. So Spring Security has a Kotlin DSL. Spring Integration has a Kotlin DSL. Spring, you can see Spring MVC and Spring Webflux have Kotlin DSLs. Spring Cloud Gateway has a Kotlin DSL. Certain projects in Spring Data have Kotlin DSLs. So the different Spring modules have all taken up the cause and all have worked to make it even more natural. In fact, Spring Framework has a DSL, so I can do functional bean registration. This is not something that's unique to Kotlin. You can do this in Java as well, but I just think it's really convenient here. So beans, and then I can just add an initializer, context. Okay, so now I'm going to functionally register bean definitions and rewrite this existing code to not use Java configuration, but to use this functional bean configuration. So let's do that here. There's one. Okay. Now remember, bean is a function. So I can do interesting things. I can say, okay, well, if math.random is greater than 0.5, then and only then should you register that bean, right? You get this nice callback. Here, I'm going to use my route locator builder, but in order for this to work, I need to inject or get a pointer to my route locator builder object, right? So I need to look that up somehow. So here you can do that using val rlb equals ref route locator builder, right? And again, I can do this because Kotlin has a very nice feature called reified or pseudo reified generic. So basically, if you look at ref, where'd you go? There it is. It says final inline fun reified t. So because this is an inline function, it's a macro. The Kotlin compiler can capture the generic parameter at the call site and then give me a pointer to that. And so I can write code where in my Kotlin code, I can actually say, what is t.class? You can't do that in Java, right? You can't say, there's no way to say new t, right? You have to capture the t.class. And that's all we're doing here is we're actually capturing it and then calling the actual code that does require the class literal. But we can do that because we have this inline reified thing. So I'm not using a class literal here. I'm using a generic parameter, and it knows that this is supposed to be a route locator builder. Or, the object is actually resolves the correct one. I can go a step further. If I remove that, it still works because the compiler figures out what it's supposed to be based on this type. T is equal to route locator builder there, right? So either way, this code works. Okay, so there's my context, my Spring application context. We don't need that at all then, right? The Java config goes away. And there's my functional reactive application with DSLs and so on. So let's go ahead and run this. Go, compile away. Okay, so go to the command line curl http localhost 8080 / proxy, right? Didn't I say that? Proxy, yeah. So we got, what did we get wrong? Is it HTTPS? Did I do the wrong URL? Oh, I should have known. Security. It should be good, but I did the wrong thing. Okay, there we go. So I proxied the request to the downstream service. Great. What about my endpoint? The endpoint that we created was called hello. So hello world. Good. So now we've looked at some of the DSLs here, and you can see that this is just the beginning. I've only shown you some This is a module from Spring Cloud and from Spring Framework. In the other really nice opportunity that we have when we use Kotlin is to take advantage of DSLs, to take advantage of these APIs. And as we move to an increasingly microservice-centric world, as we move to an increasingly concurrent world, it can be very useful to take advantage of a nice feature in Kotlin called coroutines. So I'm going to do is I'm going to build one more module here called coroutines, and this module is going to use our R2DBC, which is the reactive relational database connectivity. Right? It's going to use Postgres. It's going to be using the reactive web support, and I think that's it. That should be enough, right? I'm going to go ahead and hit generate and open this up in my IDE. Coroutines. Now, the idea here is that when we use reactive programming in the Java ecosystem, reactive programming gives me a way to tell the computer, to tell the runtime, to tell the scheduler, hey, I'm not using this thread, so I'm going to relinquish it back to you, the scheduler, so that you can give it to somebody else that's using it. That's only possible if we embrace non-blocking work, right? So if we do non-blocking I/O, then that's very useful, right? Because that gives me plenty of opportunities to tell the scheduler, hey, I'm not using this thread. The result is that I get very good efficiencies, especially in a cloud environment. I want to make sure that my CPU is being used all the time. I don't want to log into my server and see that it's idle. It's waiting for some thread to be freed up because it's doing input_stream.read and it's blocking on that read call, right? Instead, I want to ask for data and then get off the thread and not wait for the data. When the data comes back, I'll have another thread get woken up to provide the response. And this gives me much better scalability, incredible scalability. The only drawback, if there is one, is that there is a slight learning curve that's associated with understanding this new programming paradigm. The reactive streams types are more functional in nature. They're sort of like promises in other languages, right? And so if you're I've seen people struggle with that. They are not able to get their head wrapped around how to write code in this new functional way, even though I would say it's not that difficult. Look at Java 8 Streams API. It's sort of similar to that. You've got map and flat map and filter and so on. But even I can agree, however much I like the reactive streams types, that it's not as simple as doing what we did for the last 20 years, right? Which is this non-reactive, non-functional style, this very imperative style. So what I want to do now is I want to build an application that takes advantage of coroutines, which gives us the best of both worlds. Here, I'm going to build an application that has a repository. So I'll say at repository. And I'm going to create a customer repository that talks to my SQL database using my R2DBC. R2DBC is like a reactive relational database connectivity abstraction. Okay, so database client, and it's going to have some functions that return data. But remember, this is a reactive API. I would normally have to work with reactive streams types or Java 9, Java util concurrent, Java util concurrent flow types, right? But because I'm going to use coroutines, I don't have to do that. I can write code that looks like it's going to block. It's going to give me the result immediately. You can compare this more or less to async await, which originated in C# a long time ago and is now available in JavaScript, even JavaScript. It's available in Python. It's available in Rust. It's in a lot of different languages, right? Now that we've got some things very similar in Kotlin, but in Kotlin we only have one keyword that we have to know about. So they've actually done a very nice job in making this work for everybody, right? So I'm going to create a callback here, a function that returns all the data just as before. .select, and I'm going to use from customer, right, as type. Okay, and the data is going to be a type of customer. So I need a data class here. Val ID int val name string and at ID. Okay, so as customer, and then I'm going to fetch it, and then I'm going to turn it into a flow. So a flow of customer. This is great for a stream. In this case, we're not actually gaining a lot by using coroutines. Okay, but it's not worse. Before, if it was not a coroutine, this would have returned a flux of customer, but now it's a flow of customer. So for multi-valued things, not much of a difference, right? It's not better or worse really. But for single-valued things, becomes very convenient. So then find one by ID, and let's say I want to find, or by name. Let's do that, right? So by name, name string equals. And here I'm going to return a customer, just like before, right? A nullable customer. I'll say this.dbc execute select all from customer where name equals name. Okay, so I'm going to provide a parameter now. I'm going to bind it to that string that we've provided there. So name, name, right? Name. Good. And once I've bound it, I want to then turn it into a type. So as type customer and fetch, and then await one or no. These functions are extension functions that don't exist in the regular R2DBC API, but they give us the ability to now await. I'm telling the runtime, go ahead and launch this asynchronous thing, and when the results come back, resume the execution of this function where I left off, as though I'm blocking, but I'm not blocking. I'm actually going to relinquish the thread, and then the runtime will take it and give it back to somebody else. So anything that works in Reactive, any Reactive API will automatically work in this coroutine fashion, right? So anything using these Reactive Streams APIs automatically works out of the box. That's very convenient. So now all your Reactive code, if you write it from Kotlin, can use coroutines, right? You don't have to do anything special. It just works. So let me do a endpoint, an HTTP endpoint. You saw me do the functional Reactive router earlier, right? I can actually I can do something even better with coroutines. I can use a co-router instead of a router, right? You saw that in the last one. So here, co-router, and the co-router is going to be get customers. And here, I'll just return a server response, just like I did in the last example. But instead of doing body, I'm going to do body and await, right? So I'll say cr.all. There you go. Okay, so that's my functional reactive HTTP application. And notice that because, look, I'm returning a customer. It's imperative now. I don't have this functional sort of callbacks if I don't want to. I can call customer repository by name or all, and I get back things that look like collections or single values. I don't have these functional wrappers around them like a publisher. So we can run this. Should see what we want. Oh, I need a connection string, of course. Fair enough. Spring R2DBC URL R2DBC Postgres localhost orders, username orders, password orders. Okay, restart. Localhost customers, right? There's my data. All right, my friends, I hope you got something out of this. I appreciate your time. Spasiba. Thank you so much for your attention. I'm happy to answer any questions. I hope you learned a little bit about Kotlin and you can appreciate the opportunities. For me, this is a very compelling language. And you probably heard just the other day, thanks to JPoint, this wonderful show, James Gosling uses Kotlin. How cool is that, huh? You wouldn't be alone if you wanted to take your next steps with Kotlin. You can find that there's a large community full of friendly people who are happy to see you and who want to help you on your journey, including me. Thank you so much.
All right.
So what's the next step there, Oleg and Sebastian?
Sharing all of this. Yes, actually, we do have a few questions that we just can take right now. I will just read them.
Sure.
To you if you want. So the first one was while you were showing the route locator builder, and it was how does it resolve the route locator builder in the case with the reference? So it was the ref.
So it captures that. Yeah. So great question. I must have done a poor job explaining it. It keeps a pointer. It keeps a reference. It can capture a reference to the generic type. In Java, you can't do that, right? In Java, there's no way if I have a class, I can't do this. I can't, let's see, this is pseudocode, right? So void t foo t, right? There's no way for me to say t equals new t, right? I can't do that in Java. I wish I could, but that generic information is not retainable at runtime, right? But we can do that in Kotlin. We can actually retain it if we create an inline function, right? And the inline function allows us to capture t, right? So t, and that only works if it's inline though, right? And if it says reified, right? If it says reified, then I can capture what t is. I can actually say, give me t class, for example, class of t. This wouldn't compile in Java, but it works in Kotlin. So that's what we're doing there. Is I can, and because of that, what ref does behind the scenes, it says, okay, I've got the class of t, which is this generic parameter here, and then I'll go to the application context, the Spring Bean factory, and look for the bean based on the type of the class, or the class of the bean, which we can capture thanks to the generic. So that's basically it. This is Java. That doesn't compile.
So another question regarding to Kotlin DSLs. Is there a Kotlin DSL for auto configuration and Stardust?
You can use, yeah, so, great point. So you can write configuration, just like I did, Java configuration. You can write that in Kotlin, and that works. You can create that as a Spring. You can say Spring.Factories, create a text file called Spring.Factories, put the auto configuration in there just like you would any old Java or JVM-based configuration class. One place where you might benefit from from one particular feature in Kotlin is when you are trying to do configuration properties. In Spring Boot, there's properties all over the place, right? So if you go to application.properties, these properties actually come from a Java class, right? It's a class with getters and setters. So it says configuration properties, and then name, generate unique, URL, username, password, etc. So it says anything that starts with spring.r2dbc.url, spring.r2dbc.username. Well, in the old world, 6 months ago, these configuration classes had to have getters and setters, right? It's now, or maybe it's more than 6 months. It's been maybe it's a year, but it's now natural. And now in Kotlin, it's very natural to use data classes, right? Well, data classes are not getters and setters. They're, if you have immutable final fields, then it's just constructor arguments, right? There's a getter, but there's no setter. That now works. You can do that in Kotlin. We can do constructor-based configuration properties thanks to Spring Boot 2.0 and more recent releases, right? So that's a thing that you might actually find is different. You can do data class-based configuration properties, but otherwise it should be the same.
Nice. And another one that came up while you were doing the customer repository. So quote unquote, this looks very procedural with DTO services, annotations, extensions, like static methods. Can we do better in terms of OO programming? And follow-up question, or how should one test this?
Well, I mean, it's Kotlin, so you can use. I was surprised to find that even though there are some very nice testing libraries like Spec, which is based on like Spock, JUnit 5 works really well, right? JUnit 5 is the default in Spring, and JUnit 5 supports constructor injection now, so you can do val. You can say I want to inject into my constructor a field, that kind of stuff. So there's a lot of really good support there. Nothing really special. There are some nice libraries like Spec, which is kind of like the Groovy ecosystem Spock. As for being procedural, yeah, I agree. I only did all that so you could kind of see how this stuff flows together. But again, most of the time, I would just use Spring data, right? I just create an interface, customer, repository, extends, reactive, CRUD, repository, managing entities of type customer whose primary key is of type int. And there we go, right? There's my entire thing. Oh, I need to, that's why this is upset. It's simple. There you go. It's my class. There you go. So that would actually, this would give me everything I needed, right? I only wanted to do it myself so you could see the suspend functions and how that works. But this would give you a repository that has find all and save and delete and all that stuff.
Mm-hmm. Yeah, fair enough. And a different one regarding execution runtimes and reactive. Is the execution runtime different in case when we use Kotlin Flow instead of Reactor Flux?
I think it gets adapted to, but I don't know the exact. I think behind the scenes when you use Kotlin flow and all this stuff, we're adapting it to the right APIs because it's not the flow itself; it's the libraries that you're using, right? And they in turn are calling the schedulers behind the scenes in Project Reactor.
All right. So these are the questions for now. I'm pretty sure we will get more questions once folks join later on in the Q&A section. Is there anything else you have a few minutes left you want to share with us while you have the stage?
I really appreciate all of you, and I wish I could be there. I know that we're all going through a weird moment in history, and it's nice to know that we're all still together. I just really appreciate you taking the time to come watch my little talk. And that's about it.
Nice. Excellent. In the meantime, we got one more question. So since we have like 5 minutes, we're going to continue asking you the questions. So Ilya asks, how are transactions processed with coroutines? Right? Coroutines and transactions. They usually link to a thread with Spring Transaction Manager. Can you elaborate?
Yeah, so this is a reactive question, and it also works for coroutines. We have support in the reactive APIs for a reactive transaction manager. The way that works, let me create an example here. Fun, foo, whatever. So I'm doing some work here, right? And val data equals what's an example? Flux.just 1, 2, 3, right? So I've got a reactive stream there. It's a publisher of int, right? And there, data dot. So I want to visit the data, right? And I want to visit the records, and I want to do something with it, and then I want to subscribe. So subscription is what you do at the end of the reactive stream. Well, of course, the whole point of a reactive stream is that this line, this operator, may happen on a different thread than this one, which might happen on a different thread, etc. So I can't be sure on what thread something is going to execute. So to solve that problem, we created something called the subscriber context. The context is a dictionary. It's a key value store that you can use. So it's just arbitrary, any arbitrary key and value, right? Context. So there you go. So there's my context, and I can put other values as well. So key 2 and true, and key 3 and date, right? Whatever. Just any arbitrary values that can go there. So hello. Thank you. So I can use this context, and now at any point in the reactive pipeline, I can get access to that data. So do on each, I get a signal dot context dot, and then I can say, give me the key, right? So I can access that key that has been provided for me here. Well, if you understand this basic mechanism, basically this context allows me to propagate data along the life of the reactive pipeline, no matter what thread it's on. So that solves the thread local problem. Well, that's what we use behind the scenes to support distributed tracing. So if you're using Spring Cloud Sleuth and you're using reactive applications, Spring Cloud Sleuth, SLEUTH, is our distributed tracing abstraction that we introduced back in 2015. It just works with this, right? So we can trace automatically reactive APIs. If you're doing Spring Security and you want to propagate the current authenticated user. So for example, a request comes in at the very edge of the microservice. You don't want to re-authenticate on every thread. So you authenticate at the filter at the very edge of the service. You stash that authenticated user somewhere. Well, in the old world, that would be a thread local. But now we can use the context. You can also use this for, as I say, for transaction demarcation. So all that to say, if you have a reactive service, you can use Reactive Transaction Manager and then just put transactional, right? That should involve the underlying reactive APIs, right? For a reactive API, you would say class foo service. I'm not actually sure what I should try that out. I think it would still work with this, but if it doesn't, it definitely does work with something that returns a reactive stream, right? So flux of whatever, right? And I'll just flux.empty, whatever, add transactional at service. So that reactive transaction manager support is built in. It's already done for you now out of the box with Spring Boot 2.3 and later. No, 2.2 and later, right? So you don't have to do anything beyond that. Reactive transactions get configured for you if you're using something that supports reactive transactions. So Spring Data Reactive MongoDB, Spring Data Reactive Neo4j, Spring Data R2DBC, which is the SQL database API, the library I'm using. So all these things support transactions, and they support this reactive transaction manager, like so. And this looks very similar if you've ever used Platform Transaction Manager from Spring from 2 decades ago, right? So there's 2 implementations of Transaction Manager, Platform Transaction Manager. Here's the synchronous blocking non-reactive version of it. This API is one of the oldest things in Spring. It's one of the reasons that people love Spring is because I can have truly portable transactions. If I'm using, if 20 years ago or 18 years ago, I was running inside of an application server, this would automatically bind to my JTA application server transaction manager and user transaction if I wanted to, or I could use resource local transactions for JDBC or JMS and Neo4j and MongoDB and whatever. And now, as we have an increasing number of libraries that support reactive APIs, I have the reactive transaction manager that does the same thing for reactive APIs. I hope that answers your question.
Yeah, I am pretty sure it did. And you hit it also pretty much on point with the time. And there is Alexei.
Oh, good. Is he muted?
Okay, I was muted. Yeah, sorry, my
The
mistake.
world of Zoom.
Anyway, thank you very much, Guy. Thank you very much, Sebastian. Thank you very much, Oleg. And thank you very much, Josh, for this talk. This is a great honor to have all of you on board, Guy, this year in online. And I hope meet you the next year personally. So thank you very much. And now let's go to Zoom discussion zone. For our attendees, just below the player, we have the Zoom button. Push it and follow the link and go to the discussion zone. Thank you very much, guys, and see you a bit later.